So if you remember yesterday, we were doing our flip-flop. There they are, our flip-flop edition. We're going to keep going with that again today. So I thought that I would do some beach music. And I don't know if some of that was cut off and if we just started over. I'm not sure. But anyway, it's Mr. Ramsey again. We're going to start with some beach music for our subatizing. All right, what do we got? 3 and 3 is 6. All right, what do you see? 6 and 1, 7. What do you see? 3, 3, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a hard one. 10, 11. All right, we've got 4 and 0. So that's 4. All right, what have we got here? All right, I give you a few seconds to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Woo, that's a hard one. All right, what's this one? What do you see? How do you know? 6 on top, 2 on bottom. That's 8. Surfing Safari. All right, that's the good old Beach Boys, I believe, doing a surfing safari. All right, anyway, let's start with our little lesson. We're going to do kind of a review from yesterday and then add a little bit more to it. So if you remember yesterday, we started with our chart, our commutative property, but our goal or our standard is OA.3, apply the commutative property strategy for solving addition problems. And today we're going to put some subtraction in there too, subtraction. All right, so here's my little dune buggies I've got here. And I said that to commute or commutative property also means to travel. We just kind of traveled to the beach with the Beach Boy song. Excuse me. So we learned yesterday that you can change the addend. We talked about that word yesterday. And the sum will stay the same. So even though we change those addends, our sum stays the same. So like we looked yesterday, we had the tires on our beach vehicles. I don't know if you can see that far away. Let me bring it closer. So we've got our tires on our beach vehicle. So our add-ins are 2 and 3, and the sum was 5. And then we flip-flopped it around, and we said that 3 and 2, even though we changed the add-ins, the sum was still the same. So we're going to do a little bit more practice with that again today. All right, so let's start by looking at one of our dominoes. Can you see it? That one's yellow, kind of hard to tell. All right, so our numbers are 6 and 3. Is that right? 6 and 3. Okay, so then I could flip-flop it. Whoop, and it would be what? 3 and 6. So let's try it on the flip-flop. So I've got 6. 1, 2, 3, 4. Squeeze them on there. 5, 6. Got it. 6 and then 3. 1, 2, 3. All right, so 6 and 3. How much is that? Well, that's 9. But then I can also flip-flop it. So I'm going to change it around. And let's put this one here. And we'll put this one over here. So 6 and 3 is 9. So we'll also say that 3 and 6 are 9. But let's look at it on our whiteboard. Jonah wants to write the problems for us today. So come quickly, my child. So write 6 and 3.
While you're doing the supertizing, you might not have heard it, but I heard the cuckoo clock. You might have heard it because of the music.
Okay, he heard the cuckoo clock that we talked about last week. All right, write 6 and 3. Plus sign. Equals what?
8. 9.
9, yes. He's not paying attention to my lesson, is he? All right, so 6 and 3 is 9. It has the value of 9. So now we're going to flip-flop it, and we're going to do 3 and 6 has the value of 9. Okay, so we flip-flop those around. Let's look at it on our flip-flop number bond up here. So my add-ins are 6 and 3. So I've got 6 and 3. And then our answer was 9. 6 and 3 is 9. And then we're going to flip-flop it around. So tell me what it should be. Jonah, what should it be?
3 and 6.
So 3 and 6 has the value of 9. So we flip those add-ins around, but our sum is still the same. All right. I'm also going to write it down here on I guess you could call it the footbed of our flip-flop, because we're going to look at that, doing that in just a few minutes when we do some more with it. All right, anyway, so that was with our domino. We flipped it around to see the difference. All right, we're going to look at just a couple more problems. So let's do 6 and 7. So we've got 6 and 7. Remember, I'm trying to make my pom-poms or my flip-flops cute for the beach. So I've got 1, 2, 3, 4, 5, 6. We squeezed them on there. I've got 6, and then I'm going to put 7 more. 1, 2, 3, 4, 5, 6, 7. So is that right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So see if you can figure out how much that would be. 6 and 7. I think it's 13. Is that right? So Jonah be writing that for us while we flip it around. So 6 and 3. 6 and 7. 6 and 7 is what he's writing down. So now we're going to flip-flop it. And we're going to have 7 and 6. So we had 6 and 7. And then we're going to have 7 and 6. 6 and 7, 7 and 6. So he's going to write that one for us. While he's doing that on the whiteboard, I'm going to put it on our flip-flop. So we've got 6 and 7 more. And we said that that's 13. So there's our number bond. 6 and 7 is 13. So I'm going to flip it around to say 7 and 6. So 7 and 6 has the value of 13. So both of those have the same sum, the same value. So 6 and 7 is 13. We're going to flip-flop it around. 7 and 6 has the value of 13. Okay, so now one of our problems and here's what Jonah wrote. He wants you to see 6 and 7 is 13. Flip-flop it around. 7 and 6 is 13. All right, so one of our problems in our packet was, what subtraction problem can we do to help us solve this? So what subtraction problem could we do? So we talked about that a little bit yesterday before we left. So here's my flip-flop. I've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. All right, so those are the numbers that we just did. We did 6 and 7 is 13. Then we flip-flopped it, and we did 7 and 6 is 13. All right, but I'm going to take some of that away. So we have 13 in all. So let's put this here on our flip-flop. So I've got 13 in all, but I'm going to take away. So I'm going to take away... Let's take away 6. 1, 2, 3, 4, 5, 6. So I'm going to take 6 away. So how many do I have left? 1, 2, 3, 4, 5, 6, 7. I have 7 left.
7.
So 13 take away 6 is what, Jonah?
13 take away 6 is 7.
13 take away 6 is 7. Now we're going to flip-flop this just like we did with our addition. So this time I'm going to put them back. And this time, instead of taking the 6 away, I'm going to take the 7 away. So remember, we have 13 in all. I'm going to take 7 away. So we flip-flopped it. I had 13 in all. I'm taking 7 away. So who can figure out what the sum would be? What do you think it would be? It would be 6, because we're just flip-flopping those numbers around.
6.
And this would be like a fact family. You have the same numbers, 6, 7, and 13. They're just in different orders. Okay? So let's go back up here and see if we can do the domino problem and figure out what it was. So on our domino, we had 6 plus 3 is 9, and then we flipped it around. 3 plus 6 is 9. So how many did we have in all? Jonah, how many did we have in all?
9 and 6.
So we had 9 in all. And then I'm going to take, let's just take 6 away. So how many do you think would be left? If I have 9 and I take 6 away, that would be 3. All right. Can somebody come up with a different takeaway problem? Can you flip-flop those numbers around to figure it out? I still have to start with 9 because that's how many I have in all. I took 6 away last time. So how many do you think I could take away this time? I'm going to take 3 away. And my answer would be 6. So we've just flip-flopped all those numbers around. So my sum is 6. All right, let's try another one. So in your packet, one of your problems was worded this way. I'm just using different numbers though. So it says if, we'll say 5 plus 8 equals 13. So let's write that down. If 5 and 8 more has the value of 13, then that lets us know that 8 and what would be 13. So it said in the packet, if 5 and 8 has the value of 13, then we know that 8 and what, Jonah, what would go there?
5.
8 and 5 would be 13. So we just flip-flop those numbers around, okay? But it also, in a different problem, says what subtraction problem could help us figure it out? What subtraction problem? So it's like we just did. We have 13 in all. So I'm going to put 13 in all. And we're trying to take away. And so we were trying to figure out what this one would be. We already knew that we had this number. So I'm going to do take away 8 because we already had that number. And so then we find out the missing number. We find out the result is 5. Okay,
5.
So I have 13. I knew that I had 8 over here. So I did 13, take away 8, and then I was left with 5. Okay, and we can do that on a flip-flop if that helps you out since we've been doing our flip-flops. So 13 was my sum, and then I did 5 and 8. Whoop.
8.
Here we go. And then we can write all of our problems out that we just did. So we said that 5 and 8 more has the value of 13.
5 and 8, 13.
Then we can flip-flop it And it would be 8 and 5 has the same sum of 13. But now we're going to do our takeaway. What subtraction problem? So we said 13 take away 8 is 5. Now who's super smart out there and can flip-flop it for me? Let's see. 13 take away, what do you think? Jonah, do you know?
13 take away,
We did 8, so what do we need to do?
13 take away 8 equals 13 take away 5 equals 8.
There we go. He got it. 13 take away 5 equals 8. All right. So that's kind of like a fact family. You have those same numbers in that family, and we're flip-flopping it around, and that's called the commutative property. So anyway, I think our time is up. Let's say goodbye with some beach music. Everybody's learning how. Come on in safari with me. I'm embarrassing him. Anyway, bye guys.